For joining us today. So this is an event organized in light of World Soil Day. And as you know, World Soil Day is organized every year at 5th of December or in the week of 5th of December. And this year, so it goes from the FEO Global Soil Partnership. And this year the theme is Healthy Soils for Healthy Cities. And we've organized a program for you today where we have three major speakers on the topic that talk about urban soils and techno soils, soils in the urban environment. And urban soils are also important, although often overlooked, because they are covered with buildings, roads, tarmac, houses, and therefore limited in their function. But they're certainly very important for us, and also to have a healthy environment in the city. So many soils are polluted or contain remnants of garbage. We have landfills and other unnatural conditions for soils. That makes you also think about cyclicity and how we treat soils in the urban environment. We have three interesting speakers today. I'll show you the program. So we have the first speaker is ChengCheng Feng from the Wageningen University and Research Center, and she is a PhD researcher at the Soil Geography and Landscape Group, and she will talk about urban soils and research on that. The second speaker will be Przemysław Charzyński. He is from the Nicolaus Copernicus University in Torun, and he will talk about techno soils, so real urban soils, and the different forms of that. And the third speaker will be Sigrid Schmeisser. She's an artist researcher, and she will present Center to Periphery, Searching for the Dutch Mountains about landfill. So three very interesting topics, all related to soils in the urban industrial environment. And so we live in the Anthropocene. We are influencing the climate and the planet to a great extent. And some people call it the Anthropocene now as a geological time period. And it's not difficult to find evidence of human influence in soils, in fact, even in agricultural soils, but certainly in urban soils. And one example that stuck with me when I was a student in soil science a long time ago was my professor in geology, Professor Kronenberg. He mentioned that soil scientists, geologists could date the different layers in the harbor of New York by the cola bottles. And so in the top of the top layer were different types of cola bottles, and he called that the Opscene. Maybe they would call that layer the Opscene instead of the Anthropocene. Okay, that's jokingly. Let's start with the first speaker. That is ChengCheng Feng, and please go ahead and introduce yourself and go ahead with your presentation. And thank you for presenting.
Yeah. Hi, everyone. And okay, I'll just start sharing my screen. See. Can you see that?
Yep.
Okay. Yeah. Okay. Hi, everyone. Thanks for being here. And also thanks for having me here. I'm ChengCheng, a PhD candidate from the Soil Geography Landscape Group of Wageningen University. Today, I will take you on a journey from below to above, show you how soils, citizens, and earthworms are connected. So to start, a question: what's below our feet? Concrete for now, right? But also soils. So when people talk about soils, most will think of agricultural soils, of course, because of its large size and the direct link to the food we eat every day. But with a growing population and rapid urbanization, another type of soil is gaining more and more attention, which is urban soils. So urban soils are often described under the term SWITMA, which stands for soil of urban, industrial, traffic, mining, and military areas. So this term highlights that these soils are strongly shaped by human activities. In cities, they face several key threats: artificialization through constructing, failing, and sealing, contamination from industrial and traffic, and also compaction caused by also constructing and traffic. So this pressure can lead to quite common problems such as water ponding, low water infiltration in the city, and biodiversity loss, especially the soil organisms, and even health risks for residents. So it's significant to understand the ecosystem services that urban soils can deliver, not only provisioning such as food production, but also, especially, the regulating service, such as improving the water dynamics and enhancing local climate regulation. Another reason why we study urban soils is their high heterogeneity. It's a challenge, but also an exciting opportunity. So here is a collage of the soil profiles from the city of Wageningen. Here you will be able to see the parent material sand, clay, but also the traces of human interventions. So human interventions happen both below and above the ground, especially in urban areas where have the highest population density, and urban soils are often human constructed and highly managed. Compared to public green space that we mainly use for relaxing, our private gardens often receive a much more varied range of management practices, such as mowing and weeding, fertilizing, mulching, and liming. So with all these interventions, it can be hard to tell whether a soil is good or healthy without professional lab analysis. But we do have something to help us. Today's main character, the bridge between soils and citizens, earthworms. You have already seen them in the title, but let me introduce them a bit more. They are often called as soil ecosystem engineer, and sometimes even the indicator of soil health. And in their community, there are three functional groups. Let's start from the epigiant one. So they're usually small in size and live near the surface because they feed on the plant later, leaf later, and they have the whole coloration around the body to protect themselves from UV rays. And the second functional group is endogiant. They are more like grayish the whole body because they barely come to the surface, so they don't need the protection from UV rays. And they feed on soil just inside it. They create this kind of semi-permanent horizontal burrows, which looks like the green dots inside the drawing. And the third group, the functional group, it's the anisic earthworm. I think the most famous characteristics of them is that they create these vertical permanent burrows, which could be 2 or even 3 meters deep. And they are usually the largest in this group, in the community. So through borrowing and casting these behaviors, they can improve the soil structure, which enhance water infiltration, reduce water ponding problem, and also enhance soil organic matter dynamics. So what's going on and how does this bridge actually work? So in my PhD project, Wageningen, the city of life science, serves as our case study. We adopt the citizen science approach to explore the soil variability and earthworm community in private gardens. We created the Wageningen Green Survey, which helped us to draw the soil social profiles of local residents, including the information of their gardens, their management practices, and of course, their soils. To disseminate this survey, we created the 6-page flyer and the poster. So we briefly introduce our project in this flyer and provide some simple instruction for soil test. We attach peach strip to each flyer. And in the poster, the information will be a bit shorter and brief, but both of them have the QR code that directly linking to our survey. By now, we have collected around 88 responses of this survey, and one of the soil interest-related questions shows participants' great interest in soil biodiversity, especially the earthworm abundance. So in this autumn, we revisited 37 gardens of those and sampled the soils and earthworms. So by now, these 37 gardens, which quite nice spread like across the city. And now we have noted down the data for the earthworm abundance, and also the soil samples are in the process of lab analysis. Next year, we will share an overview feedback with the participants. In parallel, we run a field plot experiment that simulates urban soil conditions. Here, we construct our own soils, inoculate the anistic earthworms to assess the effect of vegetation types, anistic earthworms' presence, and topsoil depths on soil ecosystem services delivery. So here in this experiment, earthworms are treated as an environmental factor. On one hand, we want to assess which soil conditions support the earthworm's survival the best. And on the other hand, we examine how earthworms influence related soil functions. By combining the survey and the field plot experiment, we aim to explore nature-based, even earthworm-based solution and develop management recommendations that could enhance the related ecosystem service and functions such as carbon storage and water infiltration. Before we finish, here is a little more about earthworms that you might find interesting. So they begin their life inside small yellowish and green cocoons and hatch one by one when time is right. Here is a video clip of the hatching process from my previous work. So you might notice each cocoon does not only contain one baby earthworms. It usually could be like 5 or 6. And based on my personal observation, the color of the earthworm cocoons also change. At the beginning, it was more yellow-grayish, but as long as it's closer to the hatching stage, it will be more brownish and darker. And I often get funny questions since I started researching earthworms. For example, can earthworms survive after being cut in half? Maybe not intentionally cutting them in half. Sometimes it just happens as, I don't know, gardening accident. The answer is sometimes yes, but the chance is very low. And only the half with the clitellum, the band that shows maturity, can survive. So given time, it may regrow the missing part. And here I have some proof of it. So these two earthworms are the one I found from the sampling, earthworm sampling. And it's quite obvious you would see that the half, which are more transparent and thinner, are the regrowing parts from being cutted. So there is possibility, although it's really low, they might still survive from this gardening accident. Beyond these interesting stories, earthworms are not only a bridge between below ground and above ground worlds, but also a bridge between people, us, and soils. Because they are visible and relatable, they can spark our curiosity about what is happening beneath our feet. So next time you're in a garden or park, don't forget the robust engineers working quietly beneath our feet. And thank you. Any questions?
Thank you, ChengCheng. It's for your interesting presentation on your research. We have a question in the chat from David Roster, who contributed in the WRB to technosols. So you no wonder that his question is about technosols. His question is: many urban garden soils were not classified as technosols in WRB. They are urban soils, but do not have artifacts as necessary for technosols. Some might be anthrosols if there's enough long-term fertilization. So this overuse of technosols to mean urban soils is leading to a dilution of the technical WRB term, not to diminish the interest of your work. And you know that we have also one-to-one discussed about it, but maybe you can give a response, because there's this bit of confusion about urban soils and technosols.
I totally understand this point of view, and also, like, I would be honest, in our study, I wouldn't say all the soils we study are technosols, because technosols could be part of it, and indeed it could be like anthrosols. And in more general, I would call it like urban soils for most of like the aspects of the study. So technosols at the beginning was more like an inspiration for the project, but it was not the main, like the object we are researching on, and we don't classify all the objects we research as technosols.
In that sense, I understand you, but I've had similar comments in other researchers, for instance, in Eurosoils that research urban soils, the confusion about the terminology. I do think it's important because the technosoil is a scientific term with a specific definitions, and even I think in your garden soils there may not be anthrosols altogether. I have a question, and I think Dave has a follow-up question later. Why do you focus on garden soils when you study urban soils? Because urban soils are much more diverse than the gardens of houses.
So in our case, in the project, although like this presentation shows quite much about these garden soils, but our focus is not only like the garden soils, because we do have like a soil survey among our other like public urban green space. So we think this private green space could be difficult because it has limited access. So we decided to adopt citizen science approach to get this part of the data, but also at the same time we would sample other like public green space to make a combination, because we think this like strong or intensive human intervention, especially in private gardens, it might be one of the reasons why the urban soils has such high like heterogeneity. But we do want to cover like private green space and also public green space. Yeah.
But you do concentrate on green space, not on covered soils, right?
No, not covered soils.
On sealed soils. Okay.
Really uncovered, yeah.
Yeah, thank you. I think there's a question from David, but we need to have it in the chat. So we'll wait for his. In the meantime, while we wait for David's question in the chat, do you feel that policy is enough aware of the soil functions and how those functions can contribute to policy like heat management in the city or water storage?
You mean the policies that would
like the municipality or what is your experience? Do you think there is enough awareness of how soil functions can contribute to policy domain, even in the municipalities, like reducing heat stress or decreasing risk of flooding?
Okay. I do think there is a certain like part in the policies they have this part of this kind of awareness, but to me, I wouldn't think it's enough. And also like this strong connection between soil functions and soil organisms. I think it would be nice if this part of awareness could also be raised, not only to the municipality or public stakeholder level, but also more to, I don't know, citizens. If all the stakeholders' awareness could be raised, and I think it would be better or easier to implement this change.
More work to do then. And two more questions. What's the suitable temperature? That's from Nimat Ahmed. What is the suitable temperature for earthworms, or effect of what is the effect of high temperature?
Okay, the suitable temperature for earthworm, I would say it would be like early spring or late autumn, like around 10 degree and or 15 is fine, because I do realize, or like in the hot summer, especially this summer, I think many earthworms died because of the heat. When it's over 25 or something, like so many of them indeed just die from the heat. And so they would die, but I hope they could like
That's a specific temperature range. Okay, thank you. And David had another follow-up question. He said it would be interesting to do this work in real technosols with Technic material, or maybe even sealed, as defined in WRB, of many types of human-altered soil. How do earthworms do it in there? That would be an interesting question. And then, I don't know if you want to answer this or reflect on this.
So we are planning to have following like lab experiment. So in this lab experiment, in the column, we will indeed construct the soils, like constructed technosols. And there we will have the plant, maybe not plant cover, but definitely the initial earthworm lubricus traces to assess the influence of earthworms, like in this indeed human altered soil. Yeah.
And his last question was, how do you get the worms to make a heart shape?
I cropped the image and mirrored it.
Okay, good.
Yeah.
Well, ChengCheng, thank you very much for your presentation and your contribution of today. And so then we'll go to the second speaker. The second speaker is Przemysław Charzyński. Przemysław is now currently in the Philippines. So we asked him to pre-record his presentation. And he will present himself during the presentation. So let's have a look at his presentation.
Good morning. My name is Przemysław Charzyński. I work in Toruń in Poland, in Nicolaus Copernicus University in Toruń, and I would like to tell you a little bit about soils under and above Technic hard material, so the soils which are common in the cities. If you have any questions, of course, you can contact me anytime. Let's start with the issue that humans are changing the soils all the time. Of course, mostly due to agriculture. Like here, we can see the huge tractors which destroyed the soil cover in the Kansas, creating dust bowls which affected the millions of farmers in the middle of the United States. Here we can see, for example, what happened, how the houses was covered with the soil blown from the fields due to the over intensive agriculture. So humans can definitely destroy the soils, but can also create the soil, what we will be talking a little bit about. But let's see what happens in the cities. What are the main changes in the soil cover within the urban areas? It could be transported deposition due to infrastructure construction, pipelines, gas pipelines, which are all the time fixed, changed. So it is creating the soil disturbance. Its deposition long-term, like it happened in the core of the medieval cities, for example, and mixing and sealing when the soil is mixed on situ and covered with various materials. So this is described in the WRB as a chronic qualifier when the soil is covered by the hard material. We can see it on the picture, and this is one of the most common disturbances in the urban areas. So let's take a look on the example. This is Toruń from the satellite. On the second picture, we can see the airfield, sport airfield in Toruń. And some years ago, we was digging there to see how the soil was changed by humans in this area. So we made the profile of the sealed soils and, of course, reference one to compare directly here. So it looks like that. It's covered with the huge concrete slabs. We can see it on this picture, how the soil was changed. We can see the traces of the past soils, the covered by the newer deposits, bring by humans, old humic horizons. So we can see that the changes are quite substantial. We can here see, of course, also how deep it is. Practically nearly 1 meter of soil was deposited, changed, mixed, and then covered for traffic purposes, of course. And what happens in such soils? Here we have 2 graphs showing the fungi and bacteria amount under the cover in the sealed soil and in the reference soils, which is covered by grass. Definitely we can see in these most crucial layers, horizons close to the surface, where the plants are growing and taking a lot of the nutrients, the amount of both fungi and bacteria is definitely much more smaller than in the reference soil. So that's, of course, is caused by the limited access of oxygen, humidity, which is lowered due to the cover, so there is much less water. That is quite easy to understand why such things happen. That's why these soils are recognized in WRB as ecranic technosoils, because they are really different. Here we can see the example, the bike road. We can see again disturbances of such soil. It is also located very close to the very busy thoroughfare, where hundreds, thousands cars goes every day. Here I would like to pinpoint another changes which are happening in such soils, because the covering of the soils not only is limiting the exchange of gases and water, but also it is protecting the soil somehow. Because here, if we take a look on the content of polycyclic hydrocarbons, we can clearly see that in the reference soils, which is under loam, so it's not covered from the deposit of tires and combustion gases, the amount of hydrocarbons is definitely higher. So the sealing is not only destroying the soil, but also protecting. So in case, if we will remove the sealing at some point, we can have the soil which is less contaminated, for example. Same, of course, with the heavy metals, which is also less of them under the cover. Now let's go, as the title suggests, over the hard rock material. This is in WRB recognized by isolatic qualifier. This applies to the soil which doesn't have the contact with the soil surface, so it's separated. These are the soils which are on the buildings. They can develop naturally, as we can see on these pictures, even in the cracks of the walls, on the gutters, on the abandoned buildings. Here another example, this is the old agricultural building. If we go inside, we can see that the roof is destroyed. We can see the greenery below, and this is like a jungle. Nobody is coming here because the building is abandoned, and here we can see how the soil is developing on some ashes as well after the fire, and we can see the ferns, how they nicely grown even in such condition. In Polish system, we call such soils edifisols because of the Latin edificio, building, so we also separate it on the high taxonomical level. What happens if the building is abandoned? The soil starts to appear, so isolatic technosols developed. Finally, we can see something like that. This is example from the Guatemala, from Tikal, Mayan ruins. What we see on the picture, it's not the natural mound. It's the human constructed pyramid, small pyramid, which is totally after this 100 years covered with soil and vegetation. So we can see what's happened if the maintenance stopped, if there is abandon of the human structures, then on the ruins soil starts to develop, and finally covers is totally. Recently, thanks to the LIDAR technology, we discover a lot of such covered human structures abandoned hundreds or thousands years ago. But on buildings, not only naturally soil can develop. Very often the humans design the soils on the top of the buildings. It's like, for example, in this case of this linic technosol, Utric, Arenic, Ambric, and Anotransportic. These are the soil which we can see photographed by Professor Michał Jankowski, that humans constructed about 150 years ago on the forts, some military buildings to cover them, to make them more strong in case of the bombing. And here we can see beautifully designed soil to play purpose of the normal soil, to drain the surplus of water, so the trees and other plants can grow on the building to hide it from the air. So constructed soil, and this is quite common procedure to construct green roofs, as we can see it here. Example, they are multifunctional, they have a lot of ecosystem services. This is regulation like control of water flow, like local climate mitigation, thermal insulation. Air quality is better in such areas because the dust and other gases are depositing. Also, such roof gardens can be used as well for food production and cultural services, meeting points of the clerks, businessmen during the lunch break, for example. So definitely it should be done as much as possible because here, for example, on this graph, you can see the source there, how the wind also stops. So this is just a few examples of soils related to buildings and to the hard Technic material. To close my presentation, let's take a look on this short movie. This is what's happened in the cities. The children are playing in the soils, of course, not only in the cities. Such things can happen if we are not careful. The food is falling on the ground. So any research within the urban areas, the soils, not only classification, but of course related to the safety, to the risks, to the content on various elements are very important because we live, most of us, in the cities. So healthy soils shall be in the cities, like the theme of the soil, World Soil of the Day is this year. So please remember, we live on the soils and we should protect it. And even the urban soils are very precious resource and should be protected and researched. Thank you very much. I hope you enjoyed this presentation.
Good. So yeah, thanks you very much, Przemysław. That was a very interesting contribution, and I know that the Polish researchers, universities, they have a great contribution to researching technosols. Also being involved in SWITMA, you saw Przemysław with a T-shirt about SWITMA. SWITMA is a group, working group of the International Union of Soil Sciences that researches technosols and urban soils. And I think that it's an important topic that needs to be researched, and we need to know much more about urban and technosols. We also saw in the presentation by Przemysław that he named the soils fully according to WRB, and that may not be interesting for all, but at least you can see that we have the capacity to fully characterize the different types of human disturbed soils, such as technosols, with the characteristics that they have, like ecranic is sealed, etc. So you saw all this, and indeed also the soils from a flower pot or even rooftops, that we can give that a name. And that's, I think it's important because we need to recognize and be able to describe properly the object that we study in nature. Przemysław also mentioned that covered soils, so ecranic soils, sealed soils, they protect the soil from pollution. But to me, that also raised the question, where does the pollution go then? So it is certainly an indication that there is a lot of pollution source in the city, from automobiles, from weathering tires, from cars, for instance. But that material goes somewhere, and if it doesn't infiltrate in the soil, where does it go? It probably goes to the ditches and the drainage system, but then it goes to the groundwater or the surface water. So maybe, yeah, the soil is also a buffer for pollutants, where it can remain for a longer time and maybe break down as well, or maybe prevent distribution in other elements of the ecosystem. So that's a question I had from his, and also that soils. We saw a lot of examples where people limit the functions of soils, but soils in the city can have like I commented to ChengCheng's presentation, have a great contribution to living in the city, to reducing, for instance, heat stress, by evaporation from the soil or transpiration from the vegetation on an uncovered soil. And also for water storage and infiltration, some urban soils are in cities create wadis, so created flooding areas within the city that allows water to infiltrate in the soil, and also it enhances biodiversity, storage of carbon, and more. And rooftops, of course, are a very good example for Przemysław presentation as well, but that also enhance biodiversity and filter function, etc. So I think there are questions. David Roster mentioned that actually ekranik came from Russian. Thank you for that addition. They took the word from French and it used to mean screen. And as the presentation said, okay, that's interesting. So yeah, all these names in WRB, they have an origin from a local language. So and then whatever it came up first, or what is the source for that particular term that is introduced in WRB. Okay, there are more questions also relating to the presentation of ChengCheng, but we'll go first to the third presentation. So again, thank you, Przemysław, for your contribution to this event. And now we'll give the floor to Sigrid Schmeisser. Sigrid, it's your turn, please. Thank you. And thank you for joining.
Yeah, hello, everyone. Nice to meet you. I think in my video, I'm also doing the introduction, as I wasn't sure how I will be introduced. So I'll leave it to the video, and I'm looking forward to the conversation. Stefan, by the way, my video is partially blocked by some shapes and glitches. I don't know if this is the same for anyone else. Hopefully not.
No, it's well visible for other screens.
All right. Okay.
You can go ahead, Sigrid.
For the invitation. This is Center to Periphery, searching for the Dutch mountains. 3 years ago, I stood on the highest point of my province, a 50-meter high peak rising quietly behind a line of trees next to a canal and adjacent to a well-maintained golf course. On the way up, you cross mountain bike paths and semi-managed flora, trimmed twice a year. Aside from the fact that this topography rises in an environment that is otherwise close to sea level, there are more glitches in this Dutch territory that gives its history away. The most obvious signifier are several black pipes seemingly reaching deep inside this landscape. When you walk this topography, you are walking on what's known in the industry as the contact zone, a layer of soil applied to separate humans and more than humans from the below. For everyone setting foot on the green skin of this mountain, they are walking on decades worth of waste. Surplus matter, really, that form the anthropogenic strata of this landfill. Soil and waste combined thus turn into the most recent soil taxonomy, namely technosoil, or if there is no barrier, Gabic technosoil. Here, soil turns into mere so-called bioinfrastructure, enabling flora and fauna to return above. It is no surprise then that the city's metabolism may be easily forgotten over time and over generations, for these post-natural landscapes visually integrate themselves so well back into their surroundings. And whilst older generations might still remember visiting these places themselves to bring their waste, younger generations may have never even known about them. Particularly within urban territories, underground landfills turn into sites of recreation, appreciated by the community even. There are parks and playgrounds, noise walls, or even the backyard of a sports hall. Other times, the wastegate simply transforms into a new operational landscape. You might wonder then how many of these mountains, both under and overground, did the Dutch create? After all, this is a country where space is famously so scarce to the degree a whole province was created literally out of water. And as you might guess, with the first cities such as Almere on the newly created province of Flevoland, the landfill followed, repeating the material cycle. And you can see Almere there on the horizon in this image. So indeed, the Dutch had just finished the latest land reclamation project when they faced one of the most infamous contamination crises, which would cause nationwide alarm. It was the 15th of September 1979 when all of a sudden an enormous fountain sprouted meters high and lifted the pavement near a newly built housing estate in the small village of Lekkerkerk, not far from Rotterdam city. The groundwater pipeline had not only burst, but was found black and blistered. Unbeknownst to the residents, they had been living above a former landfill, carrying not only municipal waste, but also barrels of chemical waste, the latter illegally dumped by a local container company only 8 years earlier. All residents had to be evacuated, and not all chose to return. The incident of Lekkerkerk would also go down as one of the fastest cleanup efforts undertaken, thanks to the interventions of the then city mayor. And it would be one of the main reasons why legislation, including the Dutch Soil Protection Act, came to pass. Lekkerkerk effectively brought a new consciousness to the problem of material cycles, with other highly contaminated sites emerging over the next decades. And they equally raised questions on how to deal with them. Yet if a site had to be remediated as in excavated, the contaminated grounds and waste would need to be shipped somewhere. And likely they would be transferred to another landfill. Fast forward in the mid-1990s then, the European Union put pressure on its member states to reduce landfilling and introduce barrier systems to prevent contamination. And this occurred just at the same time that the Dutch started to do their own nationwide investigation to fully account for all landfills for the first time. And aside from checking dumping permits, they even had to resort to asking local populations on potentially illegal dumping they might have witnessed. In the end, the surveyors of the land and soil counted roughly 4,000 to 6,000 sites across the Netherlands. And many of these sites had been zones of extraction for peat, sand, or clay before they were reused as landfills and later covered with soil shipped from near and afar. There were also several ditches and trenches belonging to farmers, where wastes, mainly organic, had been dumped to fill them up. Upon closure, almost all of them were covered with soil. In the early days, these might have been soils of agricultural quality even, whereas today, covering soils would be typically of lower quality. And part of the investigation at the time was then also to check the height of that soil layer and whether it met the standards. Often the soil layer had to be increased. Over time, some of the sites were swallowed by urban sprawl and became part of the city. Eindhoven alone counts 17 underground landfills, and you can see some of them in this map. And here we can unearth the city's metabolism and history even, for a couple of those landfills contain Phillips waste according to records. So for instance, underneath this seemingly mundane urban park, you may unearth garbage technosol with artifacts clearly visible in the so-called contact zone. With rather efficient contemporary waste management, it is easy to forget that the center, and I use this term also for any dwelling, not just the metropolis. So the center still begets landfills to be created to this day on the alleged periphery. Despite the efforts of recycling, which are, as researcher Samantha McBride reminds us, a flawed way of dealing and thinking about waste streams, we are far away from circular means of dealing with matter, and recycling does not per se avoid the landfill. And waste incineration, on the other hand, can only shrink waste in size and volume. What's left are ashes. And unbeknownst to many, they too form the strata of a mountain like this one. Some of these sites will require indefinite aftercare, a term that refers to maintaining the site, mainly flora and fauna, but also battling potential soil erosion and indeed to monitor the landfill. But if it were not for this geospatial other, as I call it, these designated zones that receive waste, both municipal and industrial, we might look at material streams rather differently. For the time being, and despite the EU efforts to phase out landfilling, the highly engineered and wrapped up landfill, covered with soil, is likely to stay, according to experts. Particularly hazardous waste streams have no other destination. Think of asbestos, for instance. Conceptually, the idea of a landfill, a geospatial other created elsewhere, suggests a mastery of material streams, control, and importantly, distance to this day. Though the upholding of a center versus a periphery is equally flawed, for our bodies are rather entangled with our environment and are sponging up everything that is toxic on Earth, to quote environmental historians Stacy Alamo and Marco Amiro on whose work I'm building on. So Center to Periphery is an ongoing arts and science project focused on the legacy and futures of these post-natural landscapes. Through a chapter-based approach, the project unearths the inherent contradictions of these zones to this day. For the chapter Searching for the Dutch Mountains, I'm gathering the Naavos landfill data collected in individual provinces in the 1990s. And these records are slowly vanishing in archives and with environmental services, so they're not that accessible any longer either. And if you're considering that around 3% of all counted landfills were remediated, we are left with zones and patches in our surrounding that are not only witness to material cycles, but in fact living records of techno and garbage techno-soul. Eventually, this research on Dutch landfills will be shown as an installation in the World Soil Museum next year. Along with a performance that narrates the legacy of these post-natural landscapes, the installation will importantly include soil samples. And by presenting the physical cover layer of a landfill alongside with a nationwide mapping of all sites, we counteract the Cartesian gaze from above. Thereby, we bring audiences in touch with these geospatial others within cities and on the outskirts that they might have passed by, walked, or cycled on. Thank you.
Thank you very much, Sigrid. Very interesting. And yeah, this whole topic of landfills, I think many people are not aware of this, about how we treat actually garbage, even processed garbage, and that we have concentrations of that in the landscape which appear as natural elements. So it's like a landscape in disguise, that it has a nice cover, but ultimately there's a lot of remains of industrial products and remains from society there. And yeah, I was surprised that only 3% of the landfills are remediated. And it seems like I've read that people have often a better view on themselves than may be justified, because they remember especially the things and the positive things about their own history, but maybe the negative things are suppressed. And it seems that society maybe does this too, that all the things that we do to nature then is overlooked or maybe forgotten. Yeah, a question to you is,
can I answer this sentiment just briefly, Stefan?
Yes,
It's really
of course.
interesting. There's also this other concept I didn't mention in this conversation called shifting baseline syndrome. So over time and generations, if the site doesn't pose an immediate problem, it is easy to acclimatize to the environmental ruin, as they call it. I can refer to Anat Singh's work here as well, the anthropologist. And I find this also a very interesting concept that came from declined fishing stock regionally from Daniel Pauly. But then you can apply it on any sort of environmental ruin or problem that we are facing if, as I say, it doesn't cause an immediate problem. So yeah, I'm also very fascinated by the fact that we forget it because they're covered through the soil layer. And people who monitor them see them, but yeah, we don't necessarily see them so much anymore.
Yeah, exactly, because if they wouldn't have that cover, then there would be much more urgency to remediate them or to do something about it.
Yeah. And on the other hand, also I found that when I interviewed people that when you can recreate on these sites, even if you know it's slight of an odd, eerie topography, as the first site I showed, people also still appreciate them. Oh, now I can recreate on this spot as well. There are only so many green spaces I can, be in nature, quote unquote, with. So it was very interesting. But yeah, happy
In a
to.
way, that's fine. I think because it has a new function. The thing is only that we don't know, because ultimately, what you also say in your presentation, that ultimately all the waste will remain in nature, either even as ash or something, and ultimately will be a source of pollution in many cases.
Yeah.
But the question and immobilization is often the solution. Like with asbestos, I read that they can make glass, a kind of glass out of it, so that it's at least it's not directly in danger for humans anymore. But yeah, so that but so for a landfill, that you would think, okay, maybe it's now covered, then we have it protected and it has a new function, but ultimately it remains active. And that also leads to my question: what about the underlayer of landfills, where there's the contact with the natural soil below it? Is that always secured? Is there always a barrier between that, or is there direct contact between the natural soil and the garbage above it?
So in the newer landfills, the EU law has said that you have to have a barrier layer. Sometimes sites have been also chosen, for instance, because there's a specific clay, Eprician clay in Belgium, for instance, and then the plastic liner above. So there is definitely no contact. This is also a site where there was hazardous waste as well. And interestingly enough, after 100 years, they have to actually dig out this whole site and remediate it, because the quality of this liner is then said to deteriorate so much that there is this protection not anymore. And for the old site that they counted in the Netherlands, these 4,000 to 6,000 sites, there was typically not a covering layer, so there would be potentially contact with. Also, there is a groundwater level at some point as well. So then they had to, monitor them over years and see what is the problem of this waste. And do we need to need to remediate, or do we keep monitoring it? And then we're talking actually about threshold levels to they call it Volksgesundheit, so the health of the public, and the milieu, so the environment, to more than humans, and then to determine, is this an acceptable contamination we're exposed here to or not. And that led to whole the decision making then on the provincial side. And maybe what I should also mention in this context is that it also depended who is responsible for it. And this is something that then the Soil Protection Act also started to regulate in the Netherlands, who has to take care of it. And the cost of remediation was partially so high that then they looked at, okay, how problematic is it really?
Yeah. And are you confident that all these sites around the Netherlands are indeed monitored for this contact zone and the pollution possibly leaching down to deeper layers?
I wouldn't put my hand into the fire into this to say in German, but there are Umgebungsdienste, so environmental services, that have to look at these sites. And after 1987, so 10 years after Lekkerkerk, you had to actually remediate or take care of a site when you had polluted it. But most of these sites had been already established before, so during World War II times, or even prior to that. So I see sites where I'm pretty sure they are not monitored. At least there's no infrastructure in it to monitor. I don't know if they're still taking groundwater samples here and there. But yeah, that is a question I couldn't confidently answer. But I hope that they do for the ones that are classified as causing issues to this day. Yeah.
Yeah, it always your work and research always reminds me about the flow of materials. So we extract things from nature, be it far away or close by the city, and then we produce things in industrial processes, but ultimately something flows back to nature, and then how, do we think enough about these material flows? And of course the garbage heap is one of the worst examples, but and of course also polluting water, rivers, etc. But I talked once in the museum to people who manage a processing plant for garbage, so these factories that burn garbage. And then I asked, what do you do with the remains? You mentioned ashes also in your presentation, and ultimately they said it's just dilution. So we dilute it over it's put in building blocks, it's brought and it's put on the roads. So ultimately it will go back to nature. So I think it's really a relevant topic to think about as society. How do we deal with, what do we produce? Do we have alternatives for that? And also, how do we process it when it's not in use anymore? Yeah.
Yeah, absolutely. The site that I've just mentioned also receives those incineration ashes as well.
Exactly. Yeah. So that's a very important topic, I think. And David mentions the most important topic.
Yes.
The most important famous case in the US is Love Canal, Niagara
exactly.
Falls. Now, are you aware of that?
Yes, so they had built housing and I think possibly a school on top of it. Yes, and then this was a toxic waste dump, and then they realized that the same example as Kirk that this was a massive issue, and they had to evacuate everyone and undo the site.
And David said in Arnhem, apparently we put a large sculpture of a stag on top of one of the old landfills. I don't know if you know that site, but maybe something to explore.
Oh, right. Yeah. One of the sites that I've showed earlier as well, they also put land artwork on it as well for people again to appreciate a different kind of monument on a monument, if you wish.
Yeah, exactly. A different monument. Yeah. Okay, Sigrid, thanks a lot.
No, thank you. Thank you for
the contribution. Great contribution. Thanks again for joining. And now we still have 4 minutes left, and I think there were many more questions in the chat, so we'll address one or two of them. First of all, Maud Brown, is the quantity of worms, that's for ChengCheng, in soil an effective urban soil health indicator? And can it also indicate soil ecosystem services like high biodiversity, water retention, etc.?
Okay. So, I think when people talk about earthworms in the soils, there are two, I would say, important. The first one is, of course, abundance of quantity. And the second is the structure of the earthworm community, because these earthworms work a bit different. So, of course, they have to be enough number and then to be effective to influence this soil health. And second, they need to have quite a good structure of this community so they could work together to enhance the soil dynamics and also water infiltration. So the second question is, can also indicate soil ecosystem services? I would say so. First would be the biodiversity, especially soil microfauna biodiversity, and also when there is a earthworm's presence, when it's a good community structure, it also usually refers to a good water infiltration function. Maybe not specifically water retention, I'm still not sure about that, but water infiltration, yes.
Thank you. And second question by Emmanuel Nabouye. Which functional groups of earthworms, epigenic, endogic, anisic, were most prevalent in the urban soils you studied, and how did their roles differ across landscapes?
Okay, so these functional groups are, I would say, the most common one would be the endogic earthworm, but in our study, and we focus especially on this anisic one, because although endogic are the most common one, they are most of the robust one, but anisic, when they create these permanent burrows, we studied especially on this water-related function, water infiltration. And we already introduced them in our field plot experiment, and we will follow that in the further lab experiment. But for the other two functional groups, we might focus more a bit on the soil organic matter and the aggregate stability part.
Yeah. Okay, thank you. Maybe one more question for Sigrid. Do you use indicators for soil biodiversity in your research sites? If you visit sites, do you check for earthworms or other biota?
No, but I would be really interested in that. When I was listening to your presentation, ChengCheng, I was thinking maybe we should do a collaboration on one side, because now I've started to look into the flora on the landfill as well and what grows there. There are often neophytes as well that like these sort of anthropogenic soils, broadly speaking. But I would be very interested in this very first layer as well and how it behaves in different sites. Of course, it depends if the landfill is still active. So if there's still methane activity and and the soil temperature will be a bit higher as well. But on the old sites, for instance, this park that I've shown you in Eindhoven, it would be interesting to also look at that for sure. We're going to do soil sampling next year, hopefully. So then maybe you want to
take it into account.
yeah.
Okay, I think we come to the end of this event. I would like to thank first of all the speakers, ChengCheng, Feng, and Sigrid Schmeisser and Przemysław. Thank you a lot for your interesting contribution and the discussion. And I also would like to thank my co-workers, Thijsa Woudenberg and van der Woude, and Erika Henskens for helping me to organize this and do all the technical facilities. And thank you to the participants to join us today. And have a good day.